HAProxy is a free open source software written in C that provides high availability layer 4 and layer 7 load balancing and proxying. It has a reputation for being fast and efficient in terms of processor and memory usage. In this video, I want to go through the following. It's going to be a long video. I have so much good stuff for you guys in this course, right? I want to go through first how we do things today, like the current architecture and the desired architecture of things, like how do you solve load balancing, right? Then I'm going to go through the HAProxy architecture, talk about key concept and component that HAProxy have, and as I am talking, you're going to start seeing time code so you can jump in the interesting part of the video, guys. We're going to show how HAProxy can act as a TCP proxy and an HTTP proxy, or a layer 4 proxy or layer 7 proxy, which acts both as a TCP layer or as an application layer like HTTP, and a TCP layer like databases, for example, right? We're going to show this cool concept called ACL, access control lists, right? I'm going to talk about a little bit about the TLS and termination versus TLS pass-through, because I found this very fascinating in HAProxy, right? And finally, we're going to go through an example, which is the most interesting part. We're going to install HAProxy. I'm going to do a little bit of basic configuration. We're going to enable HTTPS on HAProxy because we like to take it up a notch a little bit. Okay, I'm going to use Let's Encrypt. I'm going to use No IP, which is like a free thing, right? You can do this today. You don't have to buy anything. You can do everything on your Mac. I'm going to do everything on my Mac. I'm not going to do a cloud architecture or anything. Everything, all the examples is on my Mac, right? If you have Windows, it also works too. Okay. And then finally, I'm going to enable HTTP2 in HAProxy, which is something you can do, but it's not very clear out there. People tell you that, oh, HAProxy doesn't support HTTP2. No, that's not true, right? The latest version of HAProxy actually do that, which is version, I think I'm going to use 2.0, right? But yeah, finally, we're going to summarize the whole thing. If you're interested, stay tuned. If you're new here, welcome. My name is Hussein, and this channel will discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing and hit that bell icon so you get notified every time I upload a new video. With that said, let's just jump into HAProxy, guys. All right, so here's the current architecture, right? Before any load balancing or anything, you have a beautiful application here, right? It's probably running just vanilla HTTP, maybe an REST API that you built on Express or Django, whatever, right? And that is hitting a database on the backend. Could be Postgres, could be MongoDB, could be anything else, right? And then you have your client and you give them this ugly URL that has a port in it. And you say, okay, I want to get the employees, right? And when you do that, I don't know if you noticed, what happened is we're going to hit the server and then that server hits the database, right? And then you will get the server will respond with a representation of the database results, which is usually REST. That's what the representation stands for. Usually this is JSON. You get back the JSON, then you ask another question, poof, poof, hit the database, right? Get back the result. If you hit it again, same thing, right? That's the current architecture. We all know it, right? The problem is like we have one central point of failure where this server is overloaded with all these beautiful requests, right? What do? Here's what we want to do. We spin up multiple servers with your application, and that's very easy recently. And we have shown how to spin up multiple versions of your application on different ports using Docker. Just like, literally just spin up another thing and you have a version of your application, a copy. That's amazing, guys, right? I'm going to reference the video there, how we did that, right? Because we're going to use that, okay? So we have now a version of your application running 3001, 3002, 3003, and they are exactly the same. They're hitting the same exact database, right? And you put HAProxy on top of this thing, okay? And HAProxy have two pieces of components. The backend, which you configure, says, hey, HAProxy, I have these three servers on the backend. 0, 1, 2, and 3. Okay, I want you to load balance these things, and you have no idea how much configuration you can do on the backend, guys. It's amazing. What we want to do on the backend is this. I'm communicating on vanilla unencrypted HTTP, but on the front end, that's what's called a front end. I want to listen on port 443. I want this to be secure. I want this to be certificates and all that jazz, right? And I want to use H2 because why not? Because we're fancy like that. Okay. And if you want to make a request now, look at what happened, right? You make a employee request, you make a request, it goes to this server, right? And you get back the representation. If you make another request, it goes to another server, right? If you make another request, it goes to the third server. And this algorithm is called round robin. And we're going to show how we can change the algorithm, which is pretty coolish, guys. All right. So that's what we design. That's what we're going to build here. Okay. There will be no databases in our code, but you get the idea. It should be very, very simple and straightforward application. Okay. Let's just jump into it. Okay, so as we said, this is the front end. This part is the front end, right? And this part is called the back end, right? This is very key in HAProxy, and pretty much all proxies have this concept. There's a back end, anything behind you. There's a front end, anything in front of the HAProxy or the proxy, right? HAProxy architecture. Let's talk about these little bit of things, right? So there is a concept of a front end, and we're going to talk about some configuration that are very specific to HAProxy here, okay? So a front end, anything in the front of HAProxy. Usually, this is where the HAProxy listens to, which ports of HAProxy listens to. Hey, I'm listening to port 80, for example, or 443, okay? And clients communicate with that front end, essentially, okay? And when they communicate with that front end, right, that's where the HAProxy exposes these ports, right? And here's some of the configuration that you can do on the front end. There's a timeout client. Let's talk about that one, right? Because we're going to use all of these in our configuration when we get to the example, right? So timeout client is like, how long do you want me to wait before I can disconnect the client if it's not doing anything, right? Because when the client, like a mobile phone, connects to a HAProxy, right, establish a TCP connection, right? And when you do that, it's a stateful TCP connection that is alive, that's living, right? And when you do that, usually this is memory consumption, right? Imagine you have 10,000 of those, right? So timeout client will allow HAProxy to disconnect that TCP connection if the client is idle. It's not doing anything. It's like, hey, if the client didn't do anything in 1 minute, kill it. The client is dead for me, right? Very useful timeout. That's why you have to specify these timeouts. So that's front end, because remember, front end, the clients connect to me, the front end. The bind, which probably I should have mentioned this first. The bind is which port and which IP and which interface are you listening to, right? On the front end in the HAProxy. Hey, I'm listening to port 80. Hey, I'm listening to port 443. So all the clients connect to port 80 or 443, right? 443 for HTTPS, 80 for insecure stuff. ACL that you can do here, and I don't believe you can do ACL on the back end, right? Might be wrong. But on the front end, you can do, hey, access control list, right? That means, hey, if the client is going through /admin, I don't want it to go through that path, right? Or throw in, if the page is not found, throw a page 404, okay, something like that. So you want to do some conditionals on your front ends, like, hey, if this client coming from this country, block this guy, right? I don't want anyone accessing from this country, right? This content. Let's say you're building Netflix, and this particular I don't know, the morning show. The morning show is not on Netflix; it's on Apple TV. But sure, yeah. So you don't want anyone from Asia to access the morning show, right? You want only from America. You can do this on front end with ACLs, right? Something like that, okay? Back end, anything behind the proxy. And usually you can do, say, this is a logical backend. I'm going to create a backend called everything, all my nodes, right? And you can specify multiple servers on the backend. I forgot the actual most important thing, which is the server property, okay? The server property tells you how many, so what is the server that is in the backend, right? And this is the beauty of this. You can specify server 1, server 2, server 3, and you can start doing balance and all that jazz, right, on the backend. So a front end also connects always to a backend. You have to specify which backend you want me to connect to, right? And this will going to become more clear as we go through, guys, right? So essentially, if I specify a front end, I can specify a default backend, like, hey, anything connect to always this backend, right? But you can specify a backend with with a set of servers like server 1, server 2, server 3, right, running application 1, right, and server 2, server like 9, 8, 8, 9, 10, running application 2, and that's another backend. You can create 2 backends, right? And you can say, hey, if the user doing an ACL slash app 1 is trying to access app 1, take them to this backend. If they're trying to access app 2, take them to this backend. And we're going to show that in an example, guys. Okay. And what kind of properties you can do in the backend? You cannot bind to anything because you're not really listening, right? So you're just basically forwarding stuff to the backend, right? So you can specify the server. Timeout connect, right? This is a very important thing. You are in the backend now, guys. So the HAProxy is connecting to your backend servers, these Express, these Django servers, okay? And when they try to connect, when HAProxy to connect, how long do you want HAProxy to wait before it gives up connecting? Because it's connecting, right? It's a client. HAProxy is now a client trying to connect to your backend. Do you want it to just wait forever? Bad idea, right? So you want this to be as minimal as possible. It's like, hey, make it. It's like in 300 milliseconds. If you couldn't connect, kill it. This server is probably dead, right? This backend is probably dead. Okay, use another one. Another one. Time out server. Okay, here's an interesting one, right? So if you're connecting in the backend, you're having like this backend application running on port 7777, and this is like a huge application that if you make a request to this application, it's gonna take a long time, right? I don't know, it's crunching some machine learning stuff, right? And it's doing some training. If you do that, you're synchronously waiting. So the backend, how long do you want HAProxy to wait for a response from that backend, from backend server? Do you want me to wait for 10 seconds, 30 seconds, 1 minute, 1 hour? Okay. That's a probably good idea to specify these numbers. But you might say, no, Hussein, this backend should take 30 milliseconds to execute this application. If it's taking more than 30, I want to know. I want to time out, right? I want the HAProxy to kill that connection because that is bad, right? That application app 2, for example, supposed to query and immediately give me the results, right? If it's taking a long time, I want to know about it. I want a log that tells me that, hey, time out, please. So all this nice configuration, guys. And balance. We're going to have multiple servers to play with, right? In a given backend. How do you want me to balance them, right? Default, if you don't specify that, that's round robin. Round robin, you guys like 1, 2, 3, 1, 2, 3, 3, 1, 2, 3, 1, 2, 3, 3. Chandelier. Okay. Round robin is like a 1, 2, 3, 1, 2, 3. Just like literally, just like jumps from one server to another. So yeah, that's what it does, right? So round robin, very simple stuff, default stuff. You can always use it. You can always rely on it. Least connection. We talked about these TCP full state, full connections, right? They are both on the client and on the server. How do you want me to connect to these things? As you start connecting and establishing the stateful connection, you can tell HAProxy to say, you know what? I want to connect to the least, to the connection, to the server with the least amount of TCP connections that it has, right? And you might say, how though? How? If we're using round robin, then isn't that going to be balanced? Not really, because some requests are going to take more time than other requests. Some requests will stay alive longer. So you want to hit another server that has the least number of connections, right? And obviously, there's another thing called source. So like that means it's just if you make a request, right? You want to always go to a specific server, and that's called a sticky session, essentially, right? If you're coming from this IP, the HAProxy takes a hash of this IP and then does a consistent hashing and hits one of the server. And every time, every request comes from that IP address, it's going to always go to that server, right? And some people like that. I personally think it's a bad idea, right, to stick to a server. But sometimes you really need to, right, to do that. Like, okay, all my stuff, my application is a stateful application, right? The moment I put stuff on the server, on the memory of the server, I expect it to be there. So I'm bad like that, right? I'm doing it for my own reason. Just please connect me always to that machine, right? So that's the source algorithm, okay? HAProxy architecture, let's continue. Multiple front end, you can have multiple front ends, you can have multiple back ends, and this is there's a really good use case. I'm not going to go through it in this video, but there is use cases where you can put actually multiple front ends listening on a different port, right? And Varnish is actually one example of this, right? You can have HAProxy listening on port 443 as a front end, call it HTTPS only, for example, and then put another front end listening on port 80, right? That's the vanilla unencrypted one, okay? And you can have Varnish, which is a reverse proxy, connect to the HAProxy unencrypted one, because Varnish only supports HTTP backends. It's unencrypted in the free version. In the pro version, Varnish actually, the HTTP accelerator, supports SSL backends. So you can have Varnish connects to the HTTP front end in HAProxy, which is allowed, right? And then you can have HAProxy forward all the requests from the HTTP unencrypted front end to the secure encrypted backend, which turns around and connect to the HTTPS HAProxy front end, because it's like loops it on itself, and then you can just communicate and resume the connection and encrypt it. Okay, yeah, a front end can bind to one or more ports. That's totally normal. Okay, and you can have two front ends bind to two different ports as well. Okay, a front end connects to a backend, right? All of the time, right? And you can have two front end, as we explained, right? You can have front end listens to port 80, and that forwards to an HTTPS backend, right? And that HTTPS backend is actually nothing but the HAProxy itself, right? So it will connect to itself and will fine. Hey, I do have a front end called HTTPS on port 443. So let me connect to that, and then it will just resume the connection. Let's talk about modes a little bit. TCP and HTTP modes, right? So HAProxy is one of those few proxy that actually supports layer 4 and layer 7 proxying. What the heck does that mean? It means that when you play at the TCP layer, you have very few things to work with. You have the IP address. You can see the IP address, and you can see the port, and that's it. You cannot see anything else. You can see the IP address you're coming from. You can see IP address you're going to. And that's pretty much it. You cannot see the content. You cannot trust looking at the packets because they do not make any sense at that layer. Okay, layer 4, right? There you cannot see. You cannot do rerouting. You cannot do header rewrites. Any of that stuff, right? And there's a benefits of doing that. There's cons of doing that as well. So that's the layer 4 TCP proxy, right? Layer 7, which is the HTTP proxy, works at the layer 7. That means it can actually, it can look at the data. It can see, you're going to actually /search/ this, right? Or search /app1 /app2. You're going to that thing. I can read this stuff, right? So you can do some very clever maneuvering, especially with microservices. Layer 7 proxy is almost a must, right? But here's the bad thing about layer 7 proxy, right? Layer 7 has to look at the data. To look at the data, if you're using TLS, you gotta decrypt that thing, okay? And if you're decrypting, that means you're terminating the TLS. That means your proxy is looking through your data. Maybe you're okay with that, but you just so you know, the HAProxy layer, Nginx, pretty much Caddy, I think, all of those stuff look through your data. Okay, so if you don't trust your proxy for some reason, and you have a backend that is secure, okay, and that has a certificate, and you just want the proxy to actually do a load balancing and round robin, right? And you don't want it to look, you don't want it to reroute, don't want any of that stuff. Use a layer 4 proxy because it will do a SSL pass-through, and we're going to talk about that, right? It will not terminate the TLS, right? So you can play with TCP and HTTP. I'm going to talk about that in examples. Access control lists, conditionals that applies to reroute the traffic. Hey, if you're going to this endpoint, I want you, for example, to block that, right? If someone going to admin through HAProxy, they are not allowed to go to this endpoint. I just want to block them. Admin access has to go through the server directly, for example. Just want to make my own rules. You can start pulling all these beautiful rules, guys. If you're going to app1/app1, go to this backend. If you're going to this to app2, go to this backend, to these servers, right? And you can do so much clever stuff. ACL can also be applied at the not just as a HTTP mode, which is layer 7. You can apply it to the layer 4 mode. You might say, Hussein, if I'm a layer 4, I don't see any data. Why is this useful? Well, you can do some basic stuff. It's like, hey, I can look at the IP at least. That's useful. People coming from Asia, I want them to go to this backend, which is all servers going in the Asia, right? It's all Asian, I don't know, in Singapore somewhere, right? And if someone coming from America, I want the backend to go through, I don't know, these servers that are in North Virginia, okay? And so on. So it's really cool for microservices. Let's talk a little bit about TLS termination, TLS pass-through. Very powerful concepts, right? To do TLS termination, sometimes very useful, right? The front end is TLS, the back end is HTTP, right? How the heck can you communicate to then HTTP if you're HTTPS? That's impossible, right? You gotta terminate the TLS and finish the communication in a pure unencrypted way because your backend is unsecure, right? Sometimes this is a bad idea, but this is what's gonna happen, right? TLS termination is a necessary evil. You need to terminate the TLS because I need to look, right? Because what I need to do is I need to look at your data. I need to look at your headers. I need sometimes to rewrite your headers like varnish, right? I need to cache, right? If you want me to cache, don't you? If you don't want me to cache, I have to look at your data, right? And here's the thing. It requires a certification because you want to terminate the TLS. That's your final destination as a client. The client connects to HAProxy and it terminates the TLS. Says, yo, that's me. I'm the same old G, right? You connect to me. Here's your certificate, son. That's me. I don't talk to the backend server. Terminate, talk to me. And then if you're trusted, obviously, most of the time, this layer of proxying is trusted. So you're going to talk to it and then essentially communicate with the client. And then you trust it and you continue, right? And then talk about TLS pass-through. I don't trust my load balancer. I want my backend servers already HTTPS. Why should I terminate? And I don't want caching. I'm doing enough caching on the backend. Please, you are dumb proxy. Just forward my packets and shut up, okay? That's when you want to use TLS pass-through, which is the mode that's called TCP mode, right? So my backend is TLS, and the HAProxy just proxies the packets directly, right? And the moment it proxies the packet, it creates a single end-to-end TCP connection. So even the handshake happens end-to-end. And the proxy just say, boop, 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 boop. It just forwards the connections immediately, okay? And this becomes kind of a sticky thing, right? Not really called sticky, but if I'm connecting, if I'm at the layer 4, I better forward everything. I create a NAT table, essentially. I know it's a very primitive way of describing it, but a network address translation at the HAProxy level, one implementation at least. I don't know what's the internal implementation, but I think this is one of them. You can create a table that says, hey, this IP address goes to this server, just like the router does, right? This IP address goes to this server. This IP address from this port goes to this IP address to this port. So internal port is really important here as well. There's no caching. L4, ACL only, so you can play with the IP. That's pretty much it. It's more secure because, well, I'm not looking at your data, right? HAProxy in this case also doesn't need a certification, which is beautiful. So if you backend server has HTTPS, we only need that thing, the back end certification. I don't need to put a certification on my HAProxy. But in our example, we're going to use the TLS termination. Finally, the cool part, HAProxy installation. Let's go through this, guys, right? I'm going to install HAProxy, right? I'm going to use Mac for this. So I'm going to use Brew, which is this thing that installs stuff, right? You can pretty much do the same tutorial with with Ubuntu or Raspberry Pi or anything like that, right? Just is the only difference really is just the installation of that stuff, right? Install the HAProxy. Then we're gonna do a simple front end, import 80, right? And then we're gonna have some back end with many servers, because I have spin up a multiple application. We're gonna spin up multiple lightweight applications that I've created that just do simple stuff, and then we're gonna round robin through them. We're gonna do conditional app 1, app 2. If we go to app 1, we're gonna go to this set of servers. If the user goes to app 2, we're gonna go to these user servers. And we're gonna prevent admin access. Gonna show you how to do that. And almost there. We're gonna do HTTPS, right? We're going to show how to enable HTTPS on HAProxy. We're going to use Let's Encrypt for that. Beautiful, beautiful certificate of authority for free. We're going to also use, obviously, noip.com to get us like a bogus DNS, right? Because I'm going to connect it to my Mac, right? And we're going to do an HTTP2. We're going to enable HTTP2. Let's just jump into it. All right, guys. What do we want to do first? First of all, I'm going to spin up, let's say, 4 applications that I have written before. I'm not gonna go through the process because I've done it. I'm gonna reference the video here. You can go check it out. But essentially, I have a Docker image that I created with an application that listens on certain port. I'm gonna spin up 4 applications of those. Then I'm gonna spin them on different ports. So how about we do that? So I'm gonna do Docker run -p. And the first application, I'm going to run it on port 2222, right? The application itself is running on port 9999, okay? But the exposed port is actually 2222, okay? And I want to make it detached and environment variable so we can know which application is this. I'm going to call it 2222 so we can know, right? And then call node app. And then spin it up. We have 1 application. Let's spin up application 3333, right? On 3333. Let's do 4444, almost there. These are just literally express applications listening on certain ports and just app 1. I'm going to show you that now in a second, right? So I have 4 applications. Let's go to the browser and show it to you. So 2222, 333, 444, 555. It's all running on my machine, it's Docker instances, right? On Hussein Mac, which is localhost, right? So if I go to the browser and say localhost 2222, you can say that this is the application, localhost 2222, app ID 2222, homepage, says hello, right? If I do /app1, there's an application on that called app1, says, hey, app1, page says hello. It's very simple, right? If I do app2, it says app2 page. And finally, admin, right? And the admin page, I say just like replayed, like, hey, very few people should see this. Very simple thing. So if I do 3333, app1, same thing. If I do 4444, same thing, 5555. It just tells me the application number. It's very simple. And I deliberately printed out the application so I can know which application I'm hitting, okay? It's boring, right? It's very boring. I'm not gonna give you, my users, these ports, right? It's very ugly. So what do? What we do, guys, is we spin up HAProxy. We start balancing those stuff. Let's get into it. So go to the terminal. Let's install HAProxy. Very simple to do. In Mac, you do brew. If you don't have brew, just install brew on your Mac. Very simple. Once you have that, you do install brew and install HAProxy. Okay, as simple as that. In Ubuntu, it's I think apt-get HAProxy, right? And once you have it, you have it. I have, as of making of this video, it's version 2.0.10. Pretty good enough, right? It works. Now I have HAProxy. What do I need to do? HAProxy doesn't run without configuration. You have to configure something, okay? Let's create a configuration folder. Let's create a folder here called make directory. I'm going to call it proxy, right? Clear. So I have a folder called proxy, and I'm going to create a test.cfg file, okay? I'm using Vim for that, but you can use VS Code. You can use any your favorite editor, okay? And here's what we need to do, guys. Remember what we have. What matters with HAProxy? There is a front end, there is a back end. Guys, if you have watched some HAProxies or read the document, there are also default and global. I'm not going to explain that because I found them confusing, okay? Because it just muddies the water. Let's understand what we actually need, then introduce other stuff as we need them, okay? Default and global and all that stuff, and listen, right? Front end, which listens to a port. That's what matters. Let's do that. I'm going to create a front end called, I don't know, HTTP 80. You can name it anything you want. And the moment you do that, the first parameter you want to do is actually bind. What are you listening on this front end so your consumers can connect to you? Well, I'm listening to port 80 because that's my vanilla port, right? So you can do either 0.0.0.0.0.80, okay? Which means listen to all the interfaces that you have in your network. Or you can just do this, star, whatever is easy, right? Sometimes your application, especially in the cloud, you will have multiple network interfaces as you have multiple network cards, right? And you want to know which network are you referring to. I have just the one. So I'm going to say, oh, listening to this, right? What's the next thing? Remember, guys, there is a timeout, very important. In the client, it's called timeout, very simple. It's called client because the timeout here, the client, I want to disconnect the client if they don't communicate with me in 60 seconds, right? That's what it means. Very simple stuff, right? Cool. That's the front end part. Let's build one backend. Backend, if you can read, I think you can read, but I'm just zooming just in case. I'm going to create a backend called all servers. This will literally have all my servers. And my servers are called server. I'm going to create a server 1, server 2222. And guess what? Where is my server 2222? It is 127.0.0.1 because it's running the same machine. And it's running on port 2222. Remember, guys? That's my application that we just executed. You can either use localhost or 127.0.0. That's one application. I want multiple ones, guys. Server 3333, 127.0.0.2. Sorry, 333. Server 444, 127.0.0.1, 4444. And finally, server 5555, 127.0.0.1, 5555. Cool. We have something missing here. Bunch of things, actually. Okay. How many timeouts do we have backend? We have 2 timeouts. Timeout connect. How much do you want me to wait before I give up connecting to the server, for the backend servers, all these guys for the first time? So if I attempt to this time, how long do you want me to wait? I mean, 10 seconds is really a lot, but let's say just 10 seconds. If the backend doesn't respond within 10 seconds, give up, guys. Okay. And then timeout server. If I'm communicating with the backend and I made a request, how long do you want me to wait before I give up, right? Let's say I made a request to server 333 on app 1 and app 1 was taking a long time to respond. I would say, like, I don't know, 100 seconds, just kill the server, right? You can see that this is a very general timeout, right? As you make your backend specialized, right? You can make backends for application 1, which you know it takes more time. You can have more timeouts, and backend 1 for application 1, which you know is like very fast. It could be like, hey, this has to be like takes 1 second or 2 seconds. If it's more than 2 seconds, probably is very slow, right? And guys, I'm talking in seconds. This probably should be way less, right? If you think about it. All right. The final piece, I think, if I didn't miss anything, is the front end has nothing to do with the back end. How do I connect them? Default backend. What's the default backend for this front end? The default backend is all servers. And that's it. Let's save, escape, WQ, right? How do I run? Let's see. Hopefully I don't have any errors. HAProxy, because we installed it, we can do that. -F, what configuration do you want to consume? Test.cfg. And looks like I don't have any errors. How about we go and test this thing? Localhost 80, right? Or just nothing. If I do localhost 80, I was served by the node 2222. And if I refresh, I hit the second one. But look at that, guys. This is not the round robin. Hussein, you promised that round robin. This is not round robin. I'm stuck to port 3, 4. I'm stuck to some nodes. Why is it like that? Very good question, right? We're gonna come to that. Because the default mode of communication is TCP, we're using HAProxy as a layer 4 HAProxy, as a layer 4 proxy. That means the moment the browser communicates with the HAProxy, it says, hey, this is a layer 4. So it will forward me to one of the backends and will create a stateful TCP connection. That's the browser, right? The browser is creating a TCP because it's using HTTP, which uses TCP. The underlying TCP is now connected and it's alive, because the browser wants to keep connections as alive as possible, right? So when you do that, the next request, the browser is not going to create another connection. It's going to just use the same connection, which has been established to a certain backend server. So that's why you always, sometimes when you refresh, sometimes you see it, sometimes you don't, because the browser has 6 connections to work with. This is something we talked about, right? That's why we see it sometimes confusing here. But if you go to Telnet, right, you see this very clear, right? Let's go to Telnet. Browser, and let's do this. Telnet, it's clear. I'm going to do Telnet, and I'm going to connect to 127.0.0.1 on port 80, right? And I'm connected. I am connected already because this is an HTTP server. I'm going to do a GET, right? If I do a GET, see what we get. We got 3333 immediately, right? If I do it again, I do a GET, I get 4444. If I do it again, I do a GET, I get 5555. This time, it's actually round robining, right? It is actually round robin because every telnet is actually a new TCP socket created, right? That's why it's round robining. Ringa ringa rosy, look at that. Cool stuff. Now we know this is a TCP. Might as well, we don't want to use TCP. How about I want to use HTTP mode. How do you do HTTP mode? Very simple. We say that, sir, the mode is HTTP, right? If you don't specify the mode becomes TCP by default, okay? My mode is HTTP, right? And here, my mode is also, has to match, guys. You don't want to mix mode. That's bad, right? Especially, I mean, you can have mixed mode if your front end and back end have the same mode, right? But you don't have the front end connects to a back end with different modes. That's just the recipe for disaster. I have no idea what will happen. Okay, let's run it. Now it's listening. Then, woo, refresh. Now it's more like it. It's round robining now. You know why, guys? Because the final destination here is actually HAProxy. Browser connects to HAProxy, says, hey, connect to me. That's one connection. So the TCP connection ends at the proxy. And it says, please send me this request. And the proxy, the HAProxy have the ability to funnel and load balance because it owns that stuff, right? So once the receiver request, this is a new request. Every request is a new request to it because it treats it as stateless as possible, unlike the TCP mode, which treats it as like almost stateful. It just creates a table, NAT, and then forwards it always to the same backend. Here, no, it's using the actual round robin. So like every time I refresh, every request goes to that HAProxy, and the HAProxy funnels it to the backend, which is amazing, guys. All right, isn't that amazing? All right, so we did that. We did the HTTP. We did the layer 7 proxying. Layer 7 proxying. We did the layer 4 proxying, right? How about we do this? How about we actually create 2 backends? One backend for application 1 and one backend for application 2. So that if an application 1, if someone want to go to the application 1, right? What will happen is I want it to always go to, I don't know, these two applications. 2222, 333 will be responsible for application 1. These guys will be responsible for application 2. How do I do that? If I do application 1, localhost, app 1, oh, I destroyed the server. Let's run it again. If I do that, it's still round robining on all of the servers. I don't want that. Application 1, I want just 222 and 333. Okay, how do I do that? Application 2, obviously, it's doing the same thing. It's just round robining on everything. Okay, I don't want that. So what I want to do, I want to create two backends. Backend app 1 servers. Let's be fancier, like that, camel case. And I'm going to create another backend called backend app 2 servers. And you guessed it, right? I want to use for app 1, connect us the same timeout. For app 1, I know app 1 should not take more than 10 seconds, right? To execute any request. So I'm going to use a different timeout for the server, and server 2222 127.0.0.1 2222, and then I want, didn't name it correctly, 3 127.0.0.1 333. So that's my backend app 1, and I want the timeout for app 2. I don't know. Let's put in more than that. I don't know. 300 seconds. App 2 is just very expensive. Something, I don't know, it calculates prime numbers and stuff. So server 4444 127.0.0.1 and 4444, and then you do server 5555 127.0.0.1 5555. Sweet guys. That looks good. All that stuff is good, right? So now all what we need is in the front end, we need to do a condition here, guys. And the condition is, here's the thing. I want to use an ACL, which is the access control lists, right? And I'm going to create a new control list called app1, right? This is a brand new control list called app1. And that app1 is nothing but path end. If the path ends with app1, I want you to call this request app1. And if the path ends with app2, I want you to call it app2. And here's still, this doesn't really flips the backend, right? And here's the cool part. There is a command called use backend, use underscore backend. I want you to use the backend that is called app1 servers, which is this guy, if app1. If the request is of type app1, then use this app1 servers. Forgot to add one here. And I want you to use app2 servers if the request of type app2, okay? Another way is that you can do the whole thing here as a curly braces. I'm going to show how to do that. You don't have to define it this way. This is just one way to do things, right? And guys, all the examples in the configuration, I took it and made it my own, obviously. I took it from the actual HAProxy side documentation. I'm going to reference it below, right? And I just took it and just wrote my own, essentially, ideas, okay, around it. Okay, so how about we test this thing? Now, anything that ends with app1 will go to this server backend, which is just 22 and 33. If it's app2, it will go to this guy, to these puppies, right? If it's anything else, it will use what? The default backend, which is what? All the servers. How about we do that? Save. Boo! We get yelled at. Let's see what's going on. Tries to use incompatible TCP backend. That's what we talked about. You're using a TCP backend for an HTTP frontend. I'm glad that we run into this problem, guys. So the problem is here is you're using an HTTP frontend, but the backend is actually TCP, right? Because that's the default, right? So how do you fix it? I want mode HTTP, okay? And I want here mode HTTP. Now, guys, the default section becomes very handy because like, hey, everything, if I don't specify, use these defaults, please, right? That's where the defaults come in handy. But I didn't want to introduce it in the beginning because it will be confusing. And I think you agree with me, guys, right? Now you really know what to add, right? Please, guys, do yourself a favor, never copy anything and paste it and run with it, right? Please use collateral knowledge, right? Anything you want to learn it, and then understand why are you doing it this way. Because every code you put, there's a meaning for it. And when you understand it, you become a better software engineer, you become a better SRE engineer, you become a better developer. Never copy stuff from Stack Exchange. I beg you guys, never do this, okay? Let's do this. See? No more errors. Because if you get an error, you understand, you learn. That's how life works, for God's sake, right? Let's do this now. Now, up to, we're only round robining from 444 and 5555. How coolish is this, guys, right? How cool is this, right? And app 1 is actually, it's just round robin from 22 and 33. And if I do just the home page, it's going through all of them. 2, 3, 4, 5, 2, 3, 4, 5, 2, 3, 4, 5, hot, 2, 3, hot, 2, 3, hot. Okay. Sweet. Okay, I want to do one more thing. I didn't show the balancing algorithms, okay? Let's say app 1 is a bad application that's written very statefully, okay? I'm not saying stateful applications are bad. I'm just exactly saying that. Stateful applications are bad. Okay, that's contradictory. Right, so app 1 is a stateful application and requires to be sticky, right? And that means if you connect to me for the first time from the client, right, I'm going to always forward all the requests to one and only one backend, okay? So in this case, I'm going to use the load balancing called source, I think, okay? There is a least connect. You can play with those guys. There is the round robin is the default if I don't specify it. But the balance is called source here. That means app 1, let's see. I didn't really test that, so that would be interesting. Okay, so if I go here, I'm going through all of them. If I go to app 1, I didn't change the algorithm, so I'm app 2. Let's go to app 2. App 2, flipping. App 1, stuck to 3 because we told HAProxy. And since my client IP address is not changing, obviously, unless I restart perhaps my router to get a brand new IP address, that will change. But as long as I have the same client IP address, this is going to remain the same thing, okay? Probably if I connect from my phone, this is going to be different, right? I didn't try it, but I'm going to try it. I might show it here, okay? I'm not sure, but it's going to be the same thing, essentially. Okay, so that's the idea. So we've shown this stuff, we've shown all that stuff. What's next, guys? The admin page. I want to block this thing, guys. I don't want anyone to access admin. Let's do it again. I don't want anyone to access the admin from the localhost perspective, okay? I want no one to access this, really, okay? Only when they go directly to the application like 55555/admin, they can access that. I want to do just that, right? So this is open, but I want to block this. How do I do this? Okay, very simple stuff. Let's do it. Vim test.cfg. I'm gonna copy it, by the way, guys. All this configuration will be available for you guys on the description. I'm gonna do a GitHub page, all that jazz. Still recording, cool. What else? Yes, so what I want to do here is do another ACL where if the path begins with admin, I want to block it. How do I do that? But I'm going to do it in a fancier way now. You can do still ACL and define like, I don't know, block admin, whatever, but you can do it this way as well. HTTP request. I want to deny any HTTP request if, and you can put the ACL between brackets like that. This is exactly like that, right? All right, so what I want to do, if the path has in it, and here's the thing, path-i dash M begins with admin, I want to block that thing. Okay, how do we do that? Let's start to do it. Okay, run it. I do localhost. We go forbidden. That's pretty cool, guys, isn't it? So now anything that begins with admin will be blocked, right? And you can, I'm going to reference all these ACLs, guys. All right, you can do so much stuff with HAProxy. It's amazing, guys, really, for an open source software, man. Kudos for everyone who worked on this beast of a software. All right, so, but if I do, I can access that directly. And probably if you have access to the backend server, that means you are already admin, you SSH'd or stuff, right? But public people cannot access this stuff anymore. All right, before we jump to the other stuff, which is doing HTTPS, how about we create a domain, okay? And using go to the noip.com, create a domain, and then make it point to my public IP address, right? My public IP address connects to my router, obviously. My router, I open two ports, 80 and 443, to flow through my machine, which is MAC address. So let's go show you that part. All right, guys, so I'm here in my router. I have done this before. You probably can do this as same thing, right? My device is called Hussein Mac. This is my public IP address, right, currently. And I made two rules. If it's HTTP, anyone coming to my public IP address, going through port 80, I want it to forward it to Hussein Mac, to my machine, which is also will be running HAProxy probably on port 80. And if say they doing through 443, take them to my machine as well. So that's the two rules I have here. So if I took my public IP address now, just as it is, okay, and let's first run, are we running HAProxy? Yes, we are. Okay, HAProxy is running. So if I took my public IP address and do that, it works, right? Even from my phone, if I did that, it works. But public IP addresses are ugly. So what we do, we go to newip.com, create a domain for us, and then have that domain points to the IP address. All right, so this is probably the easiest thing. Go to noip.com, guys, and just sign in. It's free. And what I'm going to do here is create a host name, essentially. I'm going to go ahead and create a new host name, DNS, right? And I don't care anything, really. You get a bogus free domain, right? Because you don't care, because you're not paying for this thing, right? So you get a bogus A record. That's what we want. We're gonna create an A record host name. So ddns.net, I'm gonna call it Hussein HAProxy. Hussein Proxy, something like that, right? Anything. I don't think anyone, there's a Hussein proxy.dns.net. That will be my website, and we're gonna be pointing to my IP address, which we just proved it works, right? So I'm gonna go ahead and create a host name, and now this thing, if I do this, after a while, it takes time to update. I'm gonna refresh whenever it's happened, right? Whenever this updates, it's gonna take some time, but once it updates, it works immediately. It's gonna work. All right, guys, so that took about 3 minutes or so, actually less than that. Now, I have a public website, husseinproxy.dns.net. It's not secure, but it's something, it's working, right? So now you have the basic pieces, right? So let's talk through this a little bit. I have a DNS on noip.com that points to my public IP address, which is my router, my local router on my machine here, my local network. My router, I configured a rule to forward port 80 and 443. Obviously, this is just port 80 because it's not secure, right? 443 will come in the future when we enable HTTPS in a minute. But port 80 forwards to my machine, which is forward to localhost, right? If I do localhost, right? That's my machine, or just Hussein Mac is another thing. You can do it this way. All of them goes to my machine, right? Cool. My machine essentially goes to the HAProxy. HAProxy talks to 4 backend servers. Coolish? Coolish. How about we start enabling my HTTPS? These are the basic stuff that we need. The next step, we're gonna connect to Let's Encrypt, get a certificate, get a public key, get a private key, okay? Merge them into one file, give it to HAProxy, says HAProxy, please listen on port 443 because now you're dope like that, okay? You're gonna listen on that thing, gonna start encrypting stuff for me, okay? And then we're gonna finish HTTPS. How about that? Let's do it. Okay, so first thing you want to do is kill HAProxy now, because nothing is running on port 80. So if I start doing this, this will fail, right? This will stay connecting, will stay connecting, and then it will just die, right? Because it's not running. Cool. What we want to do is actually install a library called Let's Encrypt. So we're going to go ahead and install it, brew and install Let's Encrypt. So that will install something called certbot, which will create a certificate for us, okay? So let's go ahead and install it. I'm not sure about the commands for apt for Ubuntu or other time, but just look them up. It's just like we're gonna install this Let's Encrypt. I'm gonna reference the libraries to do that thing. Okay, now we have certbot. This will allow us to generate a certificate, and the certificate is what identifies the server as a public IP, as a certificate authority. Let's Encrypt is a certificate authority that tells that Hussein proxy.dns.net is a legit thing that is registered with us, and we know him, and he's good, and he's a good guy, right? So that's what the certificate is, essentially. It generates two files. So let's go ahead and generate this public key, private key. And if you're confused about public and private key, we made a video about encryption. I'm going to reference it here, guys. Go check them out. I really recommend you understand that stuff. And TLS, all that stuff, I really recommend you understand how the stuff works, right? Because once on my time, I didn't understand. I just did that memory search and learned it. And I made a video so everybody can also learn. Because that's the goal of this channel. Everybody can learn, become a better software engineer altogether. All right, so now what we need to do is generate essentially a certificate. And in order to do that, we need to use sudo because it's going through certain directories. And these, if you think about it, these private key, public key are very secure. You probably only need your root to access those stuff, right? So if you do sudo certbot, right? Cert only, you can do certbot because you just installed Let's Encrypt, right, on your Mac. Okay, and you do -- standalone. And here's the thing. You're going to get asked some questions, guys. Okay, you're going to say for your password, just enter your password for that. That's the Mac password, right? I don't know why my plug is whining. Here's the thing. Now it's asking for my email address, okay? You can leave it, but you can also put an email address. I'm gonna put my email address. Feel free to contact me. It's okay, guys. And then you message just so they can email you in case something happened, right? And this is my email address. And the next step is like, what is it? Okay, please read. First, gonna agree to the things, right? I agree, right? And the next thing is like, hey, would you be willing to share your email address with Electric? No, I don't want to share. Okay. And now, please enter your domain name, comma separated. You can have multiple domain names. What's my domain name? It's called Hussein Proxy. I hope I don't butcher it. It's called .ddns. And it's very critical, guys, that you're not already listening to port 80, because what this thing does, it actually listens to port 80. That's probably why it's running as sudo, right? As well, because it needs to listen on port 80, so it can communicate with the Let's Encrypt, and it just does some negotiations like, okay, this machine is actually Hussein proxy.ddns.net. We believe this guy. He's cool, right? We do that. And just like that, it's just communicating, listening to port 80. And we get two beautiful things here, guys. We get this public key with this private key, okay? Public key, private key. Private key, just your server knows about it. Public key, everybody should know about it. It's okay. We don't care, okay? But here's the thing about HAProxy I don't really like, but sure, they work like this way. HAProxy wants one file only. They don't like the two files, right? So you have to merge these two files into one. It's not really a big deal, but what you do essentially is you cat this with this and you tee it into another file. That's just a common thing, right? So you take the content of this, merge it, write it to an M file, and give that file to HAProxy, right? So how about we do that, guys? Okay, so what we're gonna do is I'm gonna copy this guy, boop, and then do sudo, because all of these locations are very secure. They are etsy stuff, right? So you cannot just exit without it. So you have to need sudo, right? So sudo cat, take the content of this thing, right? And take the content of this thing, copy. Take the content of this thing and pipe it. This will give you a result, right? Because cat will take the content, and will give you the results and print it. I don't want to print it. I want to write it to another file. I want to write it to sudo t, right? T is actually takes the input from this first parameter and write it somewhere else. Here's what I want to write it, okay? Bad idea, but you can just decide to write it anywhere you want, right? But I'm gonna write it in a specific directory, right? Let's do that. So I'm gonna write it to users, Hussein Nasser, proxy, which is the folder we're in. I'm gonna call it HAProxy.pem, which is this extension, the same thing. But now this guy have both the private key and the public key, right? And it is in the same directory. How about that, guys, right? So now if I do this, you have the HAProxy.pem. So technically, you can go to test.cf as a CFG, the configuration, and let's bind 443, guys. Okay, I'm gonna bind, and the same. You can do the same. Let's change the front end here. I call it now HTTPS and HTTP. Whatever, right? Because now it's actually the 443. And here's the thing: you can stop here, but guess what? You're not gonna have any TLS, right? We want TLS, baby. We want TLS. So how do we do TLS? Very simple. Let's try. I'm gonna, again, all this configuration will be in the description, guys. Okay. So what do? 443. You bind it 443, but you want SSL, right? And so that means you want. I don't know what's called. It says SSL, but it's actually TLS. Nobody uses SSL free version. That's bad idea. You don't want to be down. You don't do a downgrade attack, right? That would be bad. And then CRT. Okay, the certificate. Where's my certificate, man? Where is it? It's on users, Hussein Nasser, proxy, and it's called HAProxy.pm. Hopefully I nailed that path. I'm not sure. Okay, and that's it, really, right? That's the only thing you need just to support HTTP 1.1, right? HTTP 2 is a little bit extra parameter that we're gonna talk about that in a minute. Let's do that. Now if I do HAProxy-f test, look at that. Oh, guys, look at that. We're getting a new message now. It says, son, tune the SSL the default DH parameter. It says 1024 by default. If your workload permits it, bump it up to 12. What the heck does that mean? So TLS by default, especially the latest version 1.3, which HAProxy thankfully supports, right? Uses Diffie-Hellman. That's what the DH stands for, Diffie-Hellman. And we talked about that in the encryption video and the TLS video. And Diffie-Hellman, ephemeral specifically, Diffie-Hellman uses a high, there's like a bit size of the keys, right? 1024, 2048, right? So the default for my computer for some reason says 1024. HAProxy telling us this is a bad idea because 1024 we're gonna take, I don't know, 5 years to break, right? We want to use 2048, so it can take 35 years to break a key. Okay, I'm being sarcastic here, but it is just a good idea to make your bit size as high as possible. Take one into consideration. That means if your processor supports it, because that's a crypto stuff, right? More bits, more power, more money, more problem, right? That's what happens, right? So if you have more money, just add more bits. Okay, I'm gonna shut up right now. All right, guys, we're secured now. Let's test it. All right, so this is the HTTP version, not secure. What happens if I do HTTPS? Holy moly! Look at that. I'm secure, babes. I'm secure. Valid certificate and stuff. Look at that. Look at that. And I can access it from my phone. It's secure. This certificate is valid. All that jazz. And this is public. I can give you this link and it will work, right? All the logic we did. App 1. App 1. Oh, see? App 1 is now stuck to 2222, right? I don't know. Did I change my IP address? I don't think I remember changing it. Looks like it did. App 2 is doing that thing. Home is just funneling through all of that stuff. And admin is inaccessible. Because I'm secure. I'm sending this publicly to people, to shady people, right? You don't want shady people to access admin, right? But shady people will never have access to your local host 5555 admin, right? They don't have access to this thing anymore, right? Why is this? Oh, this is HTTPS. So yeah. Get it, guys? All right. I'm secure, all that jazz. But here's my beef with this thing. If I go here and I refresh, look at this thing. What century is this? HTTP 1.1? Seriously? I'm secure? And you're telling me this is secure with HTTP 1.1? Boo! We want HTTP 2, babes. How do we do HTTP 2? Easy peasy, Japanesey. You go to tester config and Mr. HAProxy version 2, I think 1.8 support is actually, but you can just add an extra parameter here on the end. And here's what we're going to do. Okay, we're going to explain this thing. Okay, application layer protocol negotiation. And we talked about application layer protocol negotiation. This is the coolest thing, that underappreciated protocol in the entire software engineering. Okay, nobody gives rat's ass about this protocol, but it's one of the most important thing, right? Application layer protocol negotiation is an extension of TLS. And since you're doing TLS, especially 1.3, which is what HAProxy does, we're doing it in one round trip versus 2 and back in 1.2, right? Now, someone, I think Google creating, might be wrong, correct me if I'm wrong. Google said, screw this, I don't want to negotiate my protocol after TLS, right? Because that's just another request, because they say, hey, HTTP upgrade, WebSocket, HTTP upgrade, H2, right? I want to go to HTTP 2, upgrade me. This stuff is nasty, guys. You do not do another request, because you will be essentially a victim, could be potentially a victim of SSL stripping, right? Because a man-in-the-middle attack can sniff that HTTP upgrade request and say, nope, right? The server doesn't support HTTP 2. Bleh. And then they force the client to communicate with HTTP. And then this is a kind of downgrade attack if you think about it, right? We'll just, more like a downgrade attack, yeah. It's a downgrade attack, right? And also it will strip the SSL. It's actually both attacks, right? That's why Google said, you know what if part of this TLS negotiation, we said, let us do this thing during negotiation. So TLS is an extension, ALPN is an extension of TLS that can negotiate protocols during handshake. How powerful is this stuff, guys? Okay. And part of ALPN, you can negotiate what? H2, which we made a video about, because we make a video about everything software engineering, because we want to become the best software engineers on the world, guys. Okay. So you can do this, guys. ALPN, H2, right? And I want to also support, because you might want to remove this, but sure. You want to support HTTP 1.1. That's how you support both of them, right? And all of this will happen during TLS negotiation. If you're confused about TLS, watch the video that we did on TLS, right? It's very it's like a lot of people yell at me because I don't go very deep on that video, but I'm comfortable with the level I go there, because I'm a software engineer. I'm not good in network engineering. I don't know how the headers look like, and I don't care, frankly. Okay, I am a software engineer. I need to know how many round trips happening, and that's pretty much it. Okay, if you get the general idea, and that's what matters. Okay. All right. Might be wrong there. Let's save this thing and let's upgrade ourselves to HTTP 2.0. Are we HTTP 2 yet? Are we HTTP 2, sir? Or are we not HTTP 2? Babe, we are HTTP 2, son. We are HTTP 2. Done. How coolish is all this stuff, guys? All right, go back to slide. Let's summarize this thing. Summary. Oh my God, guys, this was awesome, right? I'm happy I did this video, right? I'm really happy, right? I learned a lot. I'm going to reference all the resources, all the blogs I read during this research. So you can guys, like, I created all of that stuff, right? Okay. None of the examples are copy and paste. All of the examples are mine, right? All of the examples you see here are actually I wrote them. I never copied anything, right? I read the ideas. I cannot make it out of my ass, right? I have to read, okay? Unless you're just kind of psychic, you and just understand how stuff works, right? So most of my stuff, I read it from the documentation, a couple of blogs, and that's it. Okay. Current and desired architecture, right? So we discussed that. That's the current. That's the desired. We want to enable HAProxy as a layer 7 proxy, the load balancer. That's what we did. We talked about HAProxy, the front end, the back ends, all this configuration, jazz, ACLs, right? We made an HAProxy as a TCP proxy, and we saw how it works. Powerful stuff. We made HTTP proxy, a layer 7 proxy as well. We talked about ACLs. We blocked the admin page like with ACL, because now I can look, right? I can do it. If we enable TCP and we did an ACL, it will not work, because the HAProxy will not have access to the headers or the get parameters to do that for you. TLS termination, TLS path through, powerful concepts, guys, right? And finally, we did a very lengthy example. Hope you guys enjoy this. Share it with your friends. I'm gonna break this video down into my highlight channel if you're interested to actually, like, for people who just want to learn piece of it, right? Obviously not gonna watch the whole video, but if you watch the whole video, thank you so much. Really appreciate your support. Give it a like, share with your friend. Let's make this channel reach as many people as possible so we can help change their lives, become better software engineers. We collectively become better software engineers. See you in the next one. You guys stay awesome.